Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Do you want to get better at Python? Now is an excellent time to take an online course. Whether you're just learning Python or you're looking for deep dives on topics like APIs, memory management, async and await, and more, our friends at Talk Python Training have a top-notch course for you. If you're just getting started, be sure to check out the Python for Absolute Beginners course. It's like the first year of computer science that you never took, compressed into 10 fun hours of Python coding and problem solving. Go to dataengineeringpodcast.com/talkpython today and get 10% off the course that will help you find your next level. That's dataengineeringpodcast.com/talkpython, and don't forget to thank them for supporting the show. Your host is Tobias Macy, and today I'm interviewing Kevin Stumpf about Tecton and the role that the feature store plays in a modern MLOps platform. So, Kevin, can you start by introducing yourself?
Yeah, for sure. And first of all, thanks very much for having me. Excited to be on here. I'm the co-founder and CTO of Tecton, which is the first enterprise-grade feature store.
And do you remember how you first got involved in the area of data management?
So a couple of years ago, I was one of the tech leads of Michelanagelo, which is Uber's centralized end-to-end ML platform for operational ML. And it got started in 2015, where we built this centralized system to make it really easy for data scientists and data engineers to get a machine learning model into production end-to-end, really from the entire workflow of cleaning your data, turning it into features, training the model, evaluating it, deploying it into production, and serving it in production. That's what this centralized platform allowed all the data scientists and data engineers to do. And it led to this Cambrian explosion of machine learning at Uber, and eventually led to like thousands of models that are running in production to drive things like Uber's ETAs, Uber Eats, restaurant recommendations, and a bunch of other use cases.
From that work, you have built out the Tecton platform. You mentioned that it's an enterprise-grade feature store. So I'm wondering if you can just describe a bit more about what it is that you're building at Tecton and the motivation for turning it into a business.
So what we learned with Michelanagelo at Uber, and also what we doubled down on as we talked to more enterprises, was really the understanding that building and deploying operational machine learning applications is really hard. And operational machine learning is really ML apps that are running in production that typically drive products that the customer directly interacts with. It's ML models that need to make decisions within just a couple of milliseconds and that need to run at really, really high scale, which is different to offline machine learning models. And what we've recognized is that building and deploying these applications is really hard because operational ML really consists of three different components, like an application, an ML model, and data. And let me give you an example here. Let's say an operational ML use case is an Uber Eats recommendation. You've got the application, which needs to make a prediction, and that will be the Uber Eats application or the backend. Then you've got the model, which makes actually the prediction based on a bunch of data about the user and their preferences. And then that leads to the third component, which is the data, or oftentimes referred to as the features, which are the predictive signals that the model actually makes a prediction on to indicate to you or recommend different restaurants to you. And what we've recognized is that building and deploying applications like a mobile app or a backend microservice is a fairly solved problem. Even building and training ML models and getting them into production has become an increasingly solved problem with MLOps platforms. But what has not really been solved yet is the data problem for machine learning, meaning how do you turn raw data into features that you then feed to a model that's running in production, or that you feed the data and the features consistently to your ML model training pipeline that builds the model in the first place. And at Uber with Michelanagelo, we solved the model and the data problem together. And the data problem itself, we solved with Michelangelo's component, which we call the feature store. And that is exactly what we focus on with Tecton, solving the data problems and all of the data problems around machine learning.
And before we dig too much into Tecton itself and the ideas and components of a feature store, I'm wondering if you can just give a bit more detail about what a feature actually is in the context of machine learning and maybe a particular illustration of how it differs from just a discrete data point.
Yeah, absolutely. So a feature can really be interpreted as high density information that provides a signal to an ML model to make a prediction on. And it would typically be derived off of raw data. It could be aggregated raw data. For instance, let's say for an Uber Eats recommendation, it would be like one feature that is very predictive of which restaurants to recommend to you is what is the type of cuisine that you've most frequently ordered from in the last 30 days? Or what is the restaurant that you've just clicked on 10 minutes ago? And those are all derived pieces of information that allow the ML model to come up with statistical correlations that allow it then to make a prediction for what you may really like to purchase next.
To drive that home a bit more, the raw data that those particular features might be pulling from is, you have click tracking events that are coming in through something like Segment or your customer data portal. And for the case of what purchases you've had in the past 30 days, you're looking at discrete order data so you can see what is the restaurant and then what is the category of cuisine. Is it Indian or Thai or American? And then the feature is the aggregation of those raw data points into that derived descriptor that you were mentioning.
That's exactly right.
Digging more into the feature store itself, can you discuss the different elements that go into that gives the ability to take that raw data and build these derived aggregates that can be then fed into a machine learning model?
So a feature store really manages all of your data for machine learning. And it makes it really easy for you to run data pipelines that transform the raw data and turn it into feature values. And that raw data could come from like your Kafka stream or your Kinesis stream. It could come from your data warehouse, like your Snowflake or Redshift, or it could come from your data lake, S3 and whatnot. A feature store allows you to manage these transformations, to manage these data pipelines, to automatically orchestrate them and execute them. And then it also manages the storage of these feature values, where it typically would make it possible to store those feature values for offline consumption and for online consumption. The offline consumption is necessary to drive batch predictions, like offline predictions, and to drive training processes that typically happen offline over large amounts of data. And then the online store is the one that is used to serve feature values in production to make these ultra low latency and very high scale types of predictions. And that's then where the third part of the feature store comes in, the serving of this feature data to make that feature data consistently available for training purposes and for inference purposes. And on the training side, it's typically very important that a feature store allows you to time travel to any point of time in the past and give a data scientist a snapshot of what the world looked like at any moment of time in the past so that the model can learn based on these individual data points from the past, what did the world look like and what happened to then, with that information, eventually train the ML model. And so taken together, the feature store then makes it really easy to productionize new features for a data scientist without requiring a ton of support from data engineers and whatnot. It automates the feature computation, the backfills, and all of the logging around it. And then it, of course, also makes it very easy to share and reuse those features. Once you've contributed them to a feature store, it also tracks things like the feature versions, the lineage, and all the metadata around it. And then finally, it monitors the health of those feature pipelines in production. And that is generally what feature stores as a category allow data scientists and data engineers to do. If you'd like me to, I'm happy to go into specific details about Tecton and what we've layered on besides that like core capability and feature set of Feature Store.
Yeah, definitely interested in digging a bit more into Tecton and some of the discrete elements that go into the feature store and how it shapes the integrating data teams in the lifecycle of machine learning. But before we get to that, I'm wondering if you can just give a bit of an overview about how you characterize the current state of the landscape for feature stores, because I know that it's a fairly recent category of product. And so I'm interested in understanding a bit more about your views about the level of maturity and the type of adoption that they're seeing right now.
It's definitely an up and coming category that I'd say we first coined with Michelanagelo a couple of years ago. And since we first blogged about it in 2017, we've seen how a lot of other tech companies and other companies have built their own in-house feature stores. Like you've seen things at Airbnb where they've built Zipline, Booking.com built their own feature store, Facebook has its own feature store. And so there are a lot of in-house developments, particularly at the large engineering powerhouses. Now, looking at what's been happening in the last 3 years, besides Tecton, there are other startups in the space. There's Logical Clocks and there's Stream SQL, to name two examples. There is now, since this morning, actually very apt timing, AWS has released its own feature store, which seems to really be a feature repo that allows you to store feature values and serve them in production. You still need to take care of the data preparation, the data cleaning, and all of the running of the data pipelines and whatnot yourself. But they do give you a way to store feature values and serve them consistently to training pipelines and to models that are running in production.
In terms of the overall life cycle of machine learning operations, the feature store is definitely a core component of it. And you mentioned some of the other aspects as far as model serving and deployment, and there are monitoring capabilities that are necessary there. I'm wondering if you can just give a bit of an overview about how the feature store fits and what are the additional components that are necessary to have a fully fledged machine learning operations lifecycle.
So the entire ML workflow typically consists of multiple stages. It begins with fetching the raw data, then cleaning that raw data and doing your feature engineering work to turn it into your derived feature values. Then you train your model. Once you've got your trained model, you evaluate it, you back test it and see if it is any good. Then you manage the model artifact, meaning that you store the artifact for reproducibility purposes, for versioning and whatnot. Then you deploy the model into production where you have it behind, say, a microservice. And then that microservice is able to actually make predictions in production and to monitor. Now, all of these different workflow steps, they typically require you to have MLOps platform, which allows you to train your model, manage the artifact, deploy it, and serve it in production. And then you need like a feature store to solve the data problems around machine learning that I highlighted earlier. And so with an MLOps platform and a feature store, you have a pretty good setup in order to go through the entire ML lifecycle end to end.
Some of the other interesting aspects of a feature store is the maintenance of the actual pipeline of deriving those features and some of the challenges that might come about as far as resource contention, where you want to ensure that everybody's able to build out the features that they want and that the feature stays fresh, but that you also don't overtask the platform because of maybe some unoptimized code that's actually being used to aggregate the information, where perhaps you're going with a brute force loop as opposed to a more mature algorithm that might be able to achieve the same output with fewer cycles necessary. And so I'm curious how you approach some of those types of challenges and things like Tecton for being able to ensure that you have this shared resource that's scalable and accessible, particularly for engineers who maybe aren't focused on the performance characteristics and they're just trying to achieve a certain outcome, and they might be going for a naive approach, and just how that factors into the overall development lifecycle of these features.
Yeah, definitely. So Tecton is a cloud native platform and it takes full advantage of the horizontal scaling opportunities in the cloud. So with Tecton, you don't have this noisy neighbor type problem that you've just described. And then the way that we avoid this is that the different data pipelines that generate one or multiple features, they're actually all run on independent data processing clusters. And so what we would do is we would spin up individual, on AWS, for instance, individual EMR jobs to then run Spark jobs, which process the feature values for a given feature pipeline. And that one Spark cluster is completely independent of any other Spark clusters that may be producing other types of feature values at different freshnesses, or that may be producing feature values off of a stream. So all the different pipelines are really completely independent from each other, which allows for avoiding the noisy neighbor problem, avoids the resource contention that you mentioned.
And so for data scientists or analysts who are actually building out these feature pipelines and trying to define the data aggregation to create these concrete features, what does the workflow look like, and what is their interface for being able to actually define those pipelines and manage them?
So at Tecton, we're big believers that features need to be managed as code, which allows you to bring all the DevOps best practices to machine learning, and specifically to machine learning data. And because of that fundamental belief, the interface to defining and managing your features is actually happening in Python files that are laid out in directory structure of your choosing, where you use Tecton's Python SDK to define individual feature groups. And so you define various different metadata for features, like the name of the feature, the entity it's assigned to, like a user or a transaction or something like that, the owner in the company who's responsible for it. And then you also define, of course, the transformation code itself, which could be Pandas transformation code, or it could be SQL, or it could be PySpark code. And that is all defined in these Python files on disk. And what that allows you to do is, of course, to back these Python files up in a Git repository, which gives you all the typical Git abilities like doing code reviews and whatnot. And then when you're happy with the definitions of your features, you would use Tecton's CLI in a very similar style to Terraform, run Tecton plan to look at all the Python files and all the feature definitions, and which is now your feature definition goal state, and compare it to what's currently running in production. What are all the feature pipelines that you've already configured that are running day in and day out? And then this plan shows you what is the delta of your change. Like, what are new features you're about to create? What are existing features you're about to modify that may actually impact models that are running in production? And it prevents you actually from making these changes unless you know exactly what you're doing. It is also able to show you expected costs. Like, is that actually a change you want to be making? Because it could be spinning up pretty expensive data pipelines. And then when you're happy with the plan that you're seeing, then you run Tecton apply in the CLI and actually apply these changes to the production system. And now Tecton would be running these pipelines for you on an automatic basis and store the feature values for offline and online serving. And what that tooling allows you to do is to integrate it with your existing CI and CD pipelines. So as earlier mentioned, you can use code reviews to have somebody actually approve your changes to the feature repository. You can write and run unit tests. You can write and run integration tests to ensure that the feature transformations actually all make sense and are valid. And then your CI/CD pipeline would use the CLI to actually roll out those changes to production. And then if you wanted to, you could even monitor changes. If anything looks fishy, you could kick off an automatic rollback and whatnot. And that is what the primary interface looks like to contribute new features to the feature store. Now, on the consumption side, we have two main APIs. One is, of course, the API for the online serving in production, which is a gRPC or a REST interface that you can query to fetch feature values in very low latency and at very high scale. And then there is Python SDK that you can use in your Jupyter notebooks, for instance, or on your laptop to fetch historical values from Tecton's offline feature store to generate your training data set off of which you're going to train your ML model.
Digging a bit more into Tecton itself, can you discuss how the overall platform is architected and some of the ways that the design has evolved since you first began working on it?
So the platform itself is microservice-oriented architecture. The brains of Tecton run on Kubernetes, and the main technologies that we use in our stack are Go for all of the low latency serving, and then we use Kotlin for all of the non-latency sensitive backend processes. The Python, the SDK itself is implemented in Python. And some of the major changes that we've made a little over 2 years since we've gotten started are on the customer facing front. One big change that we made was that initially the feature transformations could only be expressed using Tecton's DSL. That is something that we did at Michelanagelo beforehand as well, and it worked really well, but it is somewhat constraining. It works for a lot of different use cases, but it doesn't work for all use cases. And so we extended that interface to allow customers to also express features using SQL and PySpark directly, or just pure Python pandas related code. Then another change that we made was that initially we said, hey, Tecton itself really manages the end-to-end feature lifecycle. And that means that it manages both the feature transformations and all the data pipelines, and it takes care of the serving of feature values. But there are some customers who are actually quite happy running their own data pipelines using Airflow, using Dagster, whatever it is. And they mostly want to use Tecton to serve feature values online or offline, or to leverage its monitoring abilities, or have its central catalog. And what we then did was actually separate out the transformation capability and the storage capability, so that customers really have the choice of only using the storage and the serving without the transforms, or use the entire platform fully integrated where Tecton runs the transformations and pipelines for you as well. One of the biggest changes that we made earlier this year was adding this DevOps capability to Tecton that I've earlier mentioned, where initially you could create features only through a Python SDK in a notebook in an imperative style. But we said that in order to really support the DevOps best practices, you should be able to define your features in a declarative style in files that you can check into Git, where you can have the entire source of truth of your feature store be laid out in a file system and manages in Git. And that's when we've moved over to supporting this declarative framework, adding the CLI to run these rollouts and whatnot.
You invest so much in your data infrastructure, you simply can't afford to settle for unreliable data. Fortunately, there's hope. In the same way that New Relic, Datadog, and other application performance management solutions ensure reliable software and keep application downtime at bay, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo's end-to-end data observability platform monitors and alerts for data issues across your data warehouses, data lakes, ETL, and business intelligence. The platform uses machine learning to infer and learn your data, proactively identify data issues, assess its impact through lineage, and notify those who need to know before it impacts the business. By empowering data teams with end-to-end data reliability, Monte Carlo helps organizations save time, increase revenue, and restore trust in their data. Visit dataengineeringpodcast.com/Monte Carlo today to request a demo and see how Monte Carlo delivers data observability across your data infrastructure. The first 25 people will receive a free limited edition Monte Carlo hat. And were there any particular lessons that you learned in the process of building out Michelanagelo and interacting with the users at Uber that were useful? And what are some of the assumptions that you built up as a result of that work that proved to be invalid as you exposed the work at Tecton to a broader range of use cases and industries?
One of the things that was invalid is the one that I just mentioned, where at Michelanagelo it was totally fine to leverage a lot of the DSL to express feature transformations. And we saw that by interacting with a much broader set of customers with Tecton, we need to give customers more flexibility, allow them to write their transformations using Pandas code or PySpark code or SQL code, and not just constrain them to DSL. On the lessons that we learned at Michelanagelo that definitely proved to be true was that having a centralized platform which can standardize these workflows really is a tremendous gain of efficiency, because data scientists and data engineers, they don't need to make as many decisions about how do I define a new feature, how and where do I define a new data pipeline to run my feature transformation code. There's just one central place that you go to where you know how to use the system, and it takes care of all the heavy lifting for you. And another thing that we also learned, actually just running Michelanegelo in production and managing all of its SLAs, was how important it is to use cloud native infrastructure as much as possible. So for instance, with Tecton, our key value store is AWS, for instance, Dynamo, instead of having Tecton manage its own key value store, so that we can actually offload this burden to a managed service, which deals with supporting strong SLAs. And at Uber, for instance, we had a separate team within the company which was managing entire Cassandra clusters for all of the different infra teams that would require a key value store that's running in production.
Digging back into the workflow of the teams who are working with the feature store, both on the data engineering and data producing side, and also on the analysis and data consuming side, how do you see the feature store as changing the relationship between those different roles within the data organization?
A feature store really fundamentally empowers the data scientists. They're now able to create new features on their own and go from idea to having them in production without having to necessarily be bogged down by ML engineers or data engineers who would do the repetitive implementation work of writing these data pipelines. Whereas beforehand, if a data scientist has an idea for a new feature, they would have to typically write up feature engineering code in their Jupyter notebook, test it offline, and then eventually throw this Jupyter notebook over the wall to a data engineer or an ML engineer. And then that productionization work, where they would typically re-implement the pipeline in like Java or some other production-ready language, would have to be prioritized. The data scientists would have to wait several weeks or sometimes months to actually get this into production. And by the time everything's productionized, the data scientist may even just already be in a different team or have left the company altogether. And so with a feature store, data scientists are now really fundamentally empowered to go end to end, from turning the raw data into features, turning those features into a trained model, deploying the model using their MLOps platform into production, and then serving the features in production without having to depend too much on other teams and their own priorities.
On the side of actually connecting to the raw data, I'm wondering if you can dig a bit more into how Tecton and maybe feature stores generally interface with things like a data warehouse or a data lake or some source of streaming data, and how you approach the unification of the interface for the end user for being able to just treat all of those different data sources as a generic store of raw data.
Yeah, so Tecton itself integrates with data stores that are themselves already basically consolidated data stores. So for instance, a feature store shouldn't be confused with a massive data integrator that integrates across various different MySQL or Oracle databases across tons of different teams and organizations in a company. It really integrates with existing consolidated data sources like your data warehouse, like your centralized data lake, and your centralized streaming infrastructure, whether it's Kafka and Kinesis. And then those different data sources are onboarded onto Tecton, and the data scientist can then, without having to even know whether they're fetching raw data from a stream or from a data warehouse, write very simple SQL code or PySpark code that only deals with the raw data transformation into the feature values that they care about. And then they can rely on Tecton to actually go back to the appropriate data source to fetch the raw values. To give you one example here is if you develop a feature which turns raw data from a stream into feature values, you typically have to be able to also run backfills. And so if you create a new feature, you want to be able to bootstrap your feature store with historical feature values. Where do you get the feature? Where do you get the raw data from in order to actually process and create these historical feature values? The streaming infrastructure typically doesn't preserve all of the historical raw data. So you have to go back to a data lake or a data warehouse, which persists all of the historical raw data. And with Tecton, you're actually able to tell the system to look in, say, a Hive table for the historical raw data and to look in a Kinesis stream or a Kafka stream for the online data. And so as you create a new feature, Tecton would automatically go back to that Hive table, load all the historical raw data, bootstrap the feature store with the processed feature values, and then have a seamless handoff to now run this streaming data pipeline, which processes the raw data from your Kinesis stream or your Kafka stream.
Digging a bit more into the actual manifestation of the feature, you have this set of code that says perform these processes on the raw data to be able to create this derived attribute where, going back to our earlier example, we have the order history of the last 30 days of this particular user. And so I know that they prefer Chinese food. For the actual training of the model and for its online operation, how does that actually manifest in terms of the API? Are they sending a parameter to the feature to say, here's the customer ID, now give me back their preferred style of cuisine? Or is it something where it uses this piece of code and then generates all of the pairings of customer ID and preferred cuisine based on the historical data, and then as new information flows in, it keeps those values updated?
On the training side, there is a Python SDK where you say, hey, Tecton, give me historical feature values for this set of features. And then you can optionally filter those feature values to a set of user IDs or transaction IDs or whatever entity your features are associated with. You can also filter the features that you want the feature store to return to you by a time range. And you can also, of course, say, hey, don't filter it by anything for these 17 different features. Just give me all the historical data that you have since the dawn of time and for all of the users or transactions or whatever it is that you've ever ingested into the feature store. And then the feature store would return a data frame to you on which you do your training to generate your model. And then later on, when your model is running in production, you need to now fetch feature values for a given entity, for a given instance on which you want to make a prediction. So for instance, in the example of the Uber Eats recommendation, you have a user who opens up the app, and that user is associated with a unique ID. And then your backend system, which hosts the model and wants to make a prediction, would then call out to Tecton and say, hey, give me feature values for user X, Y, and Z. And you would then specify like which features do you actually care about? Is it the cuisine that this user has most frequently ordered from in the last 7 days? Or is it what that user has just most recently clicked on?
And then going back to another element that you brought up in terms of managing the life cycle of machine learning operations is the concept of monitoring, where I know that there is monitoring that you would do on the actual deployed model to determine things like concept drift. But I also know that with feature definitions, there's the possibility of drift there and that you want to monitor those. So I'm wondering if you can just give a bit of an overview about what types of information you're looking at when you're monitoring a feature within a feature store and some of the signals that you might be looking at to determine when you might need to update the definition of a model or redefine it entirely.
So typically what you want to make sure is that the statistics of your features do not change too much over time as your model is running in production. So for instance, for numerical features, you would look at the mean or the standard deviation and stuff like that and make sure that those stay within certain bounds, typically within the bounds that you've observed when you generated the training data set in the first place. Because if there's massive drift across any of these statistics, then that would typically mean that you should retrain your model, because the world could have just changed and it just looks different now. And you've trained your model on the state of the world and what it looked like a couple weeks, months, whatever it is ago. And if the statistics and the data don't look anymore like what they did when you first trained the model in the first place, then your model may just make really poor predictions. And so it's super important to not just monitor the predictions themselves and to check whether they're drifting, but to monitor upstream also how are the features themselves behaving and how are they changing over time. Because if you imagine that a model depends, say, on 1,000 features or so, if you were to only monitor the predictions themselves, if anything looks off here, it would be very hard to tell why does anything look off, what's the root cause for it. And you may even notice way too late that something has changed, because it's like oftentimes very minuscule, very tiny changes that may only be happening on, like, say, 1 or 2 features out of the 1,000 features. And so you really want to be looking at all of the individual features in production and remain confident that the distributions and the statistics of them are not changing too drastically over time.
Another aspect of the feature lifecycle is the idea of versioning, where you do have the original definition. You maybe then decide based on your monitoring that you need to tweak some of the parameters for this derivation function. And so then you redeploy it. If you have a machine learning model that's in production that was originally trained against the first definition of that feature, or maybe you're creating a slightly different derivation function that has a slightly different intent, how do you associate the models that are running in production with the particular version of the feature that is necessary? So doing things like version pinning and then managing releases and rollbacks for the actual feature code itself.
So in Tecton, feature definitions themselves are immutable. Once you create a new feature and you deploy it to production, it has a unique version associated with it and a unique hash associated with it. And then typically, before you use features in production, you create what we call a feature service. And a feature service is really a set of multiple different features that a model in production depends on. Say it's a selection of 10 different features, which points at 10 different features and their respective immutable versions. And this feature service now provides a unique API endpoint that your model and the microservice that hosts the model in production would query in order to fetch the feature values. And now if you, say, create a new or a changed feature, that would be a new modified feature with its own unique version. And then you would create a unique separate API endpoint, which now points at that modified set of features. And once you've trained your model and once you've deployed it, you now change that model to fetch feature values from this new updated API endpoint.
For the actual process of getting the models from training based on the generated feature data into production and running against live data that's being generated from your online feature definitions, what is the integration path for you at Tecton for being able to work with the broader ecosystem of platforms that actually manage the serving and monitoring of the models themselves, and maybe some concrete examples of a workflow from defining the model, training it on the feature definition from Tecton, and then actually getting it into production on a hosted platform or a self-managed platform?
So the interfaces that Tecton exposes to integrate with other platforms are very generic, which makes it super easy to use Tecton in your modeling platform of choice or in your production system of choice. And so to give you a concrete example, say you use Databricks notebooks or Jupyter notebooks or EMR notebooks to train your ML models. Here you would pip install and use Tecton's SDK, which is configured to connect to a specific Tecton cluster. And then there use the SDK to generate training data. And then within your model, you would, say, use scikit-learn or TensorFlow to train your model. Then you would use something like MLflow to package up that model artifact and to make it deployable. You also use something like MLflow as your model registry. And then from that notebook, you would communicate with your model serving system, whether it's Algorithmia or Selden or SageMaker, to actually deploy your wrapped up model bundle to, so that you now have a model endpoint that is available in production. And then that model endpoint would have to be called by some microservice, which actually wants to make a prediction. Microservice would integrate with Tecton's gRPC or REST API to fetch feature values for a given set of features, and then pass those features into the request to the model endpoint on, say, Algorithmia or SageMaker to make the prediction.
In terms of the actual uses of Tecton and some of the example workflows that you've seen people build, what are some of the most interesting or unexpected or innovative ways that you've seen it used?
One interesting use case that we didn't foresee ahead of time was that we have some customers who don't only use Tecton to manage their data pipelines for machine learning purposes, but also for heuristic-driven applications that are running in production that want to query some feature about a user and then make a heuristic-driven decision based on that. And in those instances, you don't need to fetch the historical data in an offline setting, because you're not, instead of training an ML model, you actually have somebody hand implement heuristics that are running directly in, say, a microservice in production. And then there they just integrate with Tecton's online serving system to fetch the fresh feature values for a given user or whatever they want to make a prediction on.
And in terms of your experience of building out Tecton and working with customers and turning it into a business, what are some of the most interesting or unexpected or challenging lessons that you've learned in that process?
One of the things that we've learned over the time was that, of course, lots of different enterprises are very different. Their preferences may be vastly different. And you have, for instance, some companies who really, really care about open source, and they really care about being able to customize whatever system they're going to use in production, or they want to be able to just manage and host it on their own. And other companies, they really just want to rely on a company like Tecton and on an enterprise software, which comes with governance, which comes with strong SLAs, which comes with support and whatnot. And we really want to be able to serve the entire market and serve both ends of that spectrum. And because of that, we've partnered up with Feast a couple of weeks ago. We've published an announcement about that last week, where the main creator of Feast, which is an open source feature store, which was created at Gojek, has decided to join Tecton, and he has contributed Feast to the Linux Foundation. And we're committed to investing significant resources to make Feast really the best open source feature store out in the industry, and give enterprises the choice whether they want to manage their own open source feature store, run it on their own, maybe customize it, or whether they want to rely on an enterprise proprietary product like Tecton.
And so for people who are considering using a feature store and they're looking at open source or managed solutions or trying to understand if a feature store is the right choice for them, what are the cases where Tecton might be the wrong choice?
Yeah, definitely. So Feast is an excellent choice for you if you care a lot about hyper customizability, where you can go in there, you can read the code, you can make changes to it, you can fork it. And we really also care about just running it on your own infrastructure, maybe even on-prem, and you want to manage and scale it yourself. Tecton is the right choice when you care about having a hosted offering, if you care about having strong SLAs and support. And also, of course, if you care a lot about governance and enterprise security and ACLs and things like disaster recovery and high availability, that's when you would come to Tecton.
And as you look to the near to medium term of the Tecton platform and the business, what are some of the things that you have planned for the future?
Over the next couple of months, we'll be announcing our support of Tecton, not just for AWS, but we'll also be releasing it on GCP as well as Azure. Besides that, we'll also make it much easier for analysts to develop their own features, specifically analysts who are not super comfortable with PySpark or with, say, Python and Pandas, but folks who really care much more about having a very intuitive and simple to use UI. And then finally, today Tecton supports like batch transformations and streaming transformations, as well as real-time transformation that are executed on demand in production when you want to get a feature value. And we are going to invest much more heavily in that area, where in the future you'll be able to execute entire DAGs of real-time features that are executed in production and that can depend on each other.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think that really, for me, comes down to end-to-end data quality monitoring and lineage tracking in an organization. Very similar to how you have things like Jaeger to do end-to-end request tracing in a distributed microservice system. I think we need something like that to track the life of a piece of data. Where does it originate from? Which systems have touched it? How does the distribution of it change over time? Who are, say, the owners of the different pipeline steps? And something like that gets especially interesting when you're crossing the boundaries between the analytical offline and the operational online stack.
Well, thank you very much for taking the time today to join me and discuss the work that you've been doing at Tecton and building out feature stores. It's definitely a very interesting area and one that I'm excited to see a lot of development on recently. So thank you for all the time and effort you've put into that, and I hope you enjoy the rest of your day.
Thank you very much.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.
Thank you.